All right, good morning, everybody. This is Dr. J, and today, we're about to be talking about some intermolecular forces. Okay, so let's get started. So I like to think of this unit as interactions. Okay, so we're going to be talking a lot of interactions today, everybody. Um, but before we get there, okay, let's just talk about a couple things. Let's look at this diagram. Let's look at this diagram. So over here on the far left, we got these atoms, right? Very compact together. In the middle, we have, right, some atoms compact together, but they're kind of loose. And then on the side here, right, we have a lot of atoms, but notice they're not together at all. They're kind of individual. So these interactions are going to play a huge role in these states of matter. All right, states of matter. So let's just break this down even further. Okay, so if we look to the far left, right, we have in this case a very compact structure. Now, this compact structure we're going to recognize is what we call a solid. Okay, so if we got the middle here, this is what we recognize as a liquid. So let's just focus on these two first. Okay. Um, Now if you add heat or if you take away heat, okay, it's going to change the way of, your states of matter or the molecule. Okay, because we're talking about interactions here, right? So let's look to these 2 points here. Kinetic energy involves the motion of molecules. Okay, the motion of molecules. And B says the potential energy involves how apart, right, those molecules are. So depending on the kinetic energy and the potential energy, that's going to give you a huge clue of what type of molecule you have. So we look here, right, the potential energy, right, is very low because our molecules aren't far apart over here. But our kinetic energy, right, also low because we don't really have any motion with our molecules. Now, there's kind of a motion here, but it's not really. But what we're going to see here is that if you add heat specifically to this solid, we're going to see that turn to a liquid, right? And guess what? Our kinetic energy is increasing because our molecules are having more motion. And let's go to the far right, right? If we add more heat, okay, then we're going to see our molecules really just have tons of motion, okay? So with this increased motion, we now have a new state, gas, okay? So if you're adding heat, you're basically adding more motion to the molecules, okay? As well as increasing our potential energy. Because notice, right, all of our molecules have gone farther apart as we go towards the right. But if we go towards the left, right, so let's go the other way. If we're in this gas state, but if we cool it down, or with gases, right, this is one thing that we're going to see. Gases are really big on pressure. So if we cool or increase the pressure, right, if you increase it, then we're going to go back to a liquid, right? And in this way, right, we're decreasing our kinetic energy and our potential energy now. And if we go towards the farthest left, right, same deal. Now we're not even moving anymore, and the potential energy is very low because they're not far apart. And this is how we have to start thinking about solids, liquids, and gases, right? So, one way that we probably thought of solids, liquids, and gases is by shape and volume, right? If you have a certain shape or a certain volume, that's going to impact, right, what type of state of matter you're going to have here. All right. So let's talk about, and once again, these are things that we probably heard of. Um, probably in grade school, second, third grade, we all had to learn, oh, this is solid, liquid, and gas, right? We all had to learn that type of stuff. But what I like to think about with Chem 2 is, we're just adding layers to common things that we already know, right? But it's a new layer to it. Okay. So if we look at gases, right? We got our states here, right? We're about to break this down. So gases normally are going to have a low density. Definitely will have a low density. And then when we're talking about shape and volume, right? We know that gases with the shape is indefinite. That means that it's not definite at all, right? It basically takes the shape of whatever container it is. If we look at this example here, right? These gases will take the shape of this container here. Okay. So it's indefinite. And our volume for gases too is also indefinite, right? Because if you put a certain amount of gas in, it will expand to take the shape, but also the volume of this container, as we see in this example here. Okay, and that's the key thing that's how we know we got gases. The shape and volume are both going to be indefinite. And if we look at liquids, right, for a long time we thought of liquids as having, higher densities, but as well, looking at the shape and volume here, the shape will be indefinite. Okay, so once again, that's basically meaning if we look at our middle picture here, it's going to take the shape of the container. All right, whatever container we got here, it's going to take the shape of that. And with the volume, right, our volume in this case, we call this definite. Now, why is it definite? Well, you put a certain amount, for instance, if I put 20 milliliters of water in this container here, right, it's not going to expand any further. It's not going to shrink unless you're doing something to it, right? You're adding heat, or if you're cooling it or some type of form like that. But if you just put 20 milliliters in a container, it's going to stay at that definite volume, 20 milliliters. Okay, not like the gas where it could potentially expand to the container. And then we got solids, right? We know about solids. Solids usually are going to be have a higher density, okay? As we look here to our picture here. And then also focusing on the shape and volume, our shape and volume for solids will always be definite. Okay, so basically, if I throw a ball in this container, right, my shape is always going to be a ball. It's not going to turn to a square. It's not going to turn to a triangle. It's always going to be that shape of that circle, right, for that ball. And that same ball, that circle, right, my volume isn't going to change, right? If I throw a pebble right into this container, it's going to stay the shape, not only the circle pebble, but it's also going to keep the same volume as that pebble, right? It's not, the pebble isn't going to get bigger, right? Or it's not going to get smaller out of nowhere, right? So it keeps the same shape and volume. Now, these are things that we probably learned in grade school, like I mentioned, or in Chem 1, depending, right? But in Chem 2, right, and this is a key thing, we're focused on intermolecular forces. And what we're going to find out with intermolecular forces is that intermolecular forces are basically impacting, right? They're going to impact our states of matter. And this is going to be this is the big thing here. So we think about gases, right? Gases have weak intermolecular forces. Okay, and we're going to get into exactly what those are in a bit. But yeah, they have weak forces, and because of that weak forces, they're impacting, right, our state of matter. Then we also have moderate forces, and moderate forces you're probably going to look at liquids. Okay, so um, not as strong as the next one we're going to cover, but definitely stronger than gas forces. And then lastly, we have solids. So solids will have the strongest intermolecular forces. Okay, and because of that, that's going to form the solid. So we're going to see trends, right, with certain intermolecular forces, right? And this is how we have to think about our states of matter, right? Intermolecular forces are the things that are impacting our states of matter. Okay, and if you got weak forces, we're talking about gases. Moderate forces, we're talking about liquids. And then strong forces, we're talking about solids.